Cyclohexane is an important cyclic alkane that consists of 6 carbons. In order to understand the stereochemistry of cyclohexane, we need to develop some understanding of the conformation of cyclohexane or the conformations in which cyclohexane exists. Let's draw the structure and then we'll make a model of cyclohexane and then we'll see what conformations we can arrive at. So this is cyclohexane. Of course, it's a 6-membered cyclic alkane. It has 6 carbons, 12 hydrogens. It's a cycle. It's a ring, obviously. And speaking of rings, of course, we always remember angle strain. The strain in cyclohexane is virtually negligible, basically virtually 0. Of course, when we speak of angle strain also, we always remember cyclopropane, which has severe angle strain. Of course, angle strain results from deviation of angles, of course, from the normal tetrahedral angle. So this is cyclohexane. It's a 6-membered cyclic alkane. Let's make a model for cyclohexane. Of course, we use this time the giant models by Darling models. This is cyclohexane. The ones in black, these connectors, if you like, in black are or represent carbon atoms. Now, of course, there's a bond between each 2 carbon atoms. So there are 6 carbons, 1, 2, 3, 4, 5, and 6. So these are the bonds. Now, if you look at the at cyclohexane, you would see you would get something like that. The bonds shown in red, they orient in the same direction, if you like. Basically, if you like, vertically or horizontally. We will see the correct descriptions of those a bit later on. So what do we see now? This is cyclohexane again. It's a cyclic alkane, 6-membered ring. So what we can get is actually something like that, or we can get something like that. Okay, so we can continue to, if you like, arrive at different conformations of cyclohexane. So if you look at this conformation, for example, this looks like a boat actually. So it's like a boat. Of course, this is one higher tip of a boat, and that's the second one. So this looks like a boat. So the ones shown, of course, in color and in the same color should be parallel with each other. The bonds shown in the same color should be parallel with each other. Now, if you take one of these carbon atoms, if you like, down, so something like this, if we take this down, then we get something like that. Now, this is no longer a boat. It looks like, if you look carefully at this model, you will probably figure out that this looks like a chair. So this looks like a chair, and of course this is like the seating part of the chair. This is like the higher tip, and this is the lower one. Okay, so this looks like a chair. This is called actually a chair conformation of cyclohexane. The one that looks like a boat is called a boat conformation of cyclohexane. Now, not only we can get this chair, we can also arrive at another chair. So this is another chair of cyclohexane. So there are therefore 2 possible chairs of any cyclohexane. This is one of them, okay, where this is like the plane, if you like, which consists, of course, of 4 carbon atoms. This carbon is slightly, or points actually upwards, if you like. This is downwards. Now, to get the other chair, you take one of these. If you this upper carbon, if you take it down, you get another boat. If you take this carbon up like that, you get also another boat. So if you get this is like a boat conformation now. If you take now this carbon, if you take it down, you get the other chair. So to go from one chair to another, you arrive at a boat transiently. So there are 2 chairs separated by a boat. So you go from one chair to a boat and then another chair. So these 4 carbon atoms, okay, do not change basically. So you only change or rotate around these carbons. So you take this, if this is now up, okay, you take it down and then you take this carbon up in order to get the other chair. So what do we learn from this model? Well, the ones shown, the carbon-carbon bonds shown in the same color are actually parallel with each other. Now, if you look at this, for instance, if you look at this model now in front of the whiteboard, and if you consider this carbon to be number 1, that's number 2, number 3, number 4, number 5, number 6, you will see that the bond between 2 and 3, which is shown in yellow, is actually parallel with the bond between 5 and 6. So these two bonds are parallel with each other. So that's exactly why they are shown in the same color. So this is something very important. This is something that will guide us into the proper drawing, if you like, of cyclohexane. If you look at the bond between 1 and 2 and the bond between 4 and 5, they are shown in green. So they are in green and they are parallel with each other. You would be able to tell that very easily, okay, that the bond between 1 and 2 and 4 and 5 are actually parallel with each other. They are shown in green for clarity. Now, if you look at the bond between 3 and 4, which is shown in black, and the bond between 6 and 1, which is also shown in black, you will see that it's actually, the two bonds are actually parallel also with each other. That's why they are shown in the same color. And if you look carefully, you can tell that very easily. So the bond between 1 and 2 is parallel to the bond between 4 and 5. The bond between 2 and 3 is parallel to the bond between 5 and 6. The bond between 3 and 4 is parallel with the bond between 6 and 1. So how would this help us in the drawing? Okay, let's begin with drawing a bond between 5 and 6. This is the bond between 5 and 6. Let's put numbers. So this is 5, that's 6. So it's like now we have drawn this line. Basically, this is carbon number 5, that's carbon number 6. Now that bond, 5 and 6, which we have just drawn, should be parallel with the bond between 2 and 3. So this should be carbon number 2, and that's carbon number 3. If you look at these two lines, they're actually parallel with each other, but this line between 6 and 5, or this bond, it's like a little bit ahead. It's like a departing or taking off airplane, which is a little bit ahead of another airplane, if you like. So these two bonds, okay, the ones in yellow again are parallel with each other, but it's like this bond is a little bit ahead, okay, if you view it like that. So this is reflected actually in the way these are drawn. Now, what we need to draw next is the bonds between, for example, either the ones in black or the ones in green. In green, it doesn't really matter. Now, if you draw a bond between 3 and 4, remember, this should be, which is in black, this should be parallel with this one. So this bond should be parallel with this bond. That's why they are in the same, or they are shown in the same color. So something like that is possible. Something like this is possible. So this bond is that one, and this bond is that one. So therefore, this is carbon number 4. This is carbon number 4. And this is carbon number, this one here is carbon number 1. So that's carbon number 1. So what we have just done is we have drawn a bond between 3 and 4 and 1 and 6. And between 3 and 4, 1 and 6, of course, these two bonds are parallel with each other. They are the ones, again, which are shown in black. Now, if you look at the bonds in green between 3 and between 4 and 5 and 1 and 2, they should also be parallel with each other. So we can actually also draw them. So this is a bond between 1 and 2, and this is a bond between 5 and 4. So this is 4. If we take it a little bit longer, that's 4. So the bond again between 4 and 5 is parallel with the bond between 2 and 1. These two bonds are shown in green. So this bond should be parallel with that one. This bond should be parallel with that one. this bond should be parallel with that one. So this actually a model of this type helps us in drawing a proper, if you like, chair conformation of a cyclohexane. So it's not really random. So this is the correct drawing of a cyclohexane in a chair conformation. Okay, not that one. Okay, if we really want to show or understand stereochemistry, if you like. Now, not only that, if you look at the bonds shown in blue, you will see they are actually vertically oriented. So this is oriented up, but vertically. This is up vertically, and that's up vertically. So let's do that. Okay, so let's draw these bonds. So this is a bond. So that one on carbon number 4. Now this bond, since it's oriented, or in the conformation it orients up or vertically, if you like. This is called axial. So this is an axial bond, and of course the axial bonds are actually shown in blue. So there is an axial bond on carbon number 4 in blue, but there is another on carbon number 2. So there is an axial bond here also. So there is, of course, hydrogen. That's hydrogen. So axial, if you look at C3, the axial bond is not actually pointed up, but rather pointed down. We'll come to them. Now, if you look at C6, it has also an axial bond which points up. So they of course point in different directions in an alternate way. Now, the bonds on C2 and C4 and C6, they point up. They are axially up. So this is axial up, if you like. Okay, so is these two. So they are axially up oriented, if you like. Now, the one on one, the carbon-hydrogen bond on 1 is also axial, but it points down. The one on 3 is also down, and the one on 5 is also axial down. So these are axial bonds also, but they are down. Now, if you look at the number of axial bonds, or the number of axial bonds in cyclohexane, the blue ones, for example, okay, there are 6 of them. 3 of them point up, and the other 3 point down. So there are 3 bonds which are axially up, and there are 3 bonds which are axially down. So these are the axial bonds. So six axial bonds, therefore. So there are 6 axial bonds, but there are 12 bonds, of course. 12, of course. When we talk about bonds, or what we mean by bonds, are carbon-hydrogen bonds in this case. Now, what about the other bonds? Okay, if you look at the other bonds in red, you would see that they are not actually axial, but they point equatorially. So these ones, okay, the bonds which are shown in red are actually equatorial, because they are not axially oriented, they are actually horizontally oriented. So how do we draw them? Well, we begin with C4, so something like that. So this is an equatorial bond, and if you basically it's this carbon-hydrogen bond. Now this carbon-hydrogen bond is actually parallel with this bond. So this CH bond is parallel with the C2, C3 bond. And again, this fact should be reflected in drawing, yeah? Okay, so this CH bond is an equatorial carbon-hydrogen bond. So that's an equatorial one. Now, we can draw also an equatorial bond on carbon number 1. So this carbon-hydrogen bond, which is this one, this carbon-hydrogen bond, is actually parallel to the bond between 6 and 5. So this is another equatorial bond which we can draw. So that's an equatorial bond, the second one. Now, there are 4 more to go. Now, we can draw another one here. So this bond, this carbon-hydrogen bond, is also equatorial. And if you look at this carbon-hydrogen bond, you will see that's actually parallel with the green bonds with the green bonds, the bonds between 4 and 5 basically, and 2 and 1. So the C3 hydrogen is parallel with C4, C5 bond and C2, C1 bond. So basically the green bonds. Now, so that's the carbon-hydrogen bond, which is equatorial on carbon number 3. We can draw another one here, the carbon-hydrogen bond between C6 and 3. And if you look at that one, this carbon-hydrogen bond, again, you will see it's also parallel with the green ones, actually, yeah? Okay, so this bond is actually parallel with that, which is parallel with that as well. So that's the fourth equatorial bond. If you look at this equatorial bond, it's actually pointed down a little. And this equatorial bond is actually pointed up a little. And that's because of course, because of the way they appear in the chair conformation, yeah. So this CH bond, it's equatorial, it is equatorial, it points up a little, and this is also equatorial, which points down a little, and this is always the case, of course, regardless of what chair do you talk about, yeah. Okay, so we have drawn so far 4 equatorial bonds. We have 2 more to go on carbons number 2 and carbon number 5. So the equatorial bond on carbon number 2, this is carbon number 2 basically. This equatorial bond should actually be parallel with the black bonds, if you like. The bonds between 4 and 3 and 6 and 1. So this equatorial bond, this CH bond, should be parallel with that line and this line. So this is how we should draw it actually. C2 hydrogen bond should be parallel. This bond here should be parallel with that bond and that bond, the bond between C3 and C4, and that between 1 and 6. We are left out with 1 more to go, the one on C5, which should be drawn like this. And that bond is actually this bond here. And that bond, C5 hydrogen, is actually, again, parallel with the black bonds. So C5 hydrogen is parallel with the black bond, the bond between C3 and C4, and the bond between C1 and C6. So this bond actually and that one are parallel with those black bonds as shown by the model. So if you look at this equatorial bond, actually it points in this direction slightly up, and that carbon-hydrogen bond, which is also equatorial, it points in that direction but slightly down. So care should be exercised here if somebody attempts at drawing equatorial bonds on these on these carbon atoms, basically carbons number 2 and 5. So this is a proper drawing of a chair conformation of cyclohexane, taking into account the relationship between these carbons according to the model that we have constructed. So not only there are 6 axial bonds, there are also 6 equatorial bonds. And again, amongst these 6 axial bonds, there are 3 axial up and 3 up and 3 down. So 3 axial up and 3 axial down. This gives us, of course, 6 axial bonds. So there are 12, of course, again, if we go back to the model, there are 12 bonds, 12 carbon-hydrogen bonds. 3 of them are axially up, 3 of them are axially down. So again, if you look at the blue bonds, carbon-hydrogen bonds, they point actually 3 of them up, and the other 3 point down, and they are in an alternate way. So you get an axial up on one carbon, but then axial down on another axial up, axial down, axial up, axial down. The ones which are represented horizontally, okay, are called equatorial bond. Of course, the term equatorial comes from the equator. Now, if you interconvert from one chair into another, so if you just remember this model now, the axial bonds are actually blue, the equatorial bonds are red. If we go from this chair to the other chair, every axial bond becomes equatorial. The blue bonds now are actually equatorial, not axial. They were axial in the previous chair, but now they are equatorial if you look at the red ones, which were equatorial, they become now axial. So this is also a fact. Any axial bond becomes equatorial in one chair, becomes equatorial in the other chair, and vice versa. And again, this is one chair. Remember, again, the red ones are axial, blue ones are equatorial. We go to the boat and the other chair, and now there we go. The blue ones are now axial, the red ones are equatorial. Red ones are axial, the blue ones are equatorial. Okay, so these are the conformations of cyclohexane. Amongst others, obviously, there are other conformations of cyclohexane, but they don't contribute as much, or they are not as important, if you like, as chair conformations and, of course, the boat. Of course, the chair is more important because it has less strain, therefore it is more stable. So this chair conformation, therefore, is the best conformation energetically, if you like, or based on stability for cyclohexane.